Assalamualaikum warahmatullahi wabarakatuh, and hello to all the viewers that see this video. So this video about comparison on 132 kV grounding system, which is task from BEF34603 electrical power transmission and distribution. Before we go any further, I would like to thank you to Dr. Farida Hanim binti Muhammad Noh as our lecturer for letting us to present our poster proposal using this video. So in this task, we have 3 group members, which is the first one is me, Muhammad Nur Aiman bin Muhammad Said. The second person is Muhammad Khairuzaman binti Muhammad bin Muhammad Jamri, and the third one is Muhammad Kamal Amza bin Kamal. So next, okay, this is our poster, which is we cannot afford to present by this poster because we have a technical problem, such as we don't know how to zoom in into each of word in this poster. So we decided to use slideshow, but it contain with the same text in the poster to let you guys to read the content. So the first one is abstract. This paper is concerned with 132 kV earthing system that contain brand, structure, cost, application, advantage and disadvantage. The type of 132 kV earth system depends on type and structure of the area, where some areas have low resistance and must use the appropriate type of grounding system. So introduction for this project is, in substation earthing system is essential not only to provide the protection of people working in vicinity of earthing facilities and equipment against danger of electrical shock, but to maintain proper function of electrical system. Reliability and security are to be taken in consideration, as well as adherence to statutory obligation, that is IEE standard on electrical safety 1/2 and environmental aspect. Earthing system, those design must be easily maintained, and future expansion must be taken into account while designing the dimension of earth mat. So our objective for this project is understanding the concept of transmission and distribution system component. The second one is compare the component between conventional and modern latest technology. And then the third one, the last one, investigate modern and conventional transmission and distribution system. So in this task, we are going through the old system and a new system, so you can see the different and which is good for us to use in our opinion. So for the other part of this presentation, I will let my friend to continue. Thank you.
So for the brand for this project is, first, the conventional is copper rod, and the modern is electrolytic iron ground rod. Company name of copper rod is Xinjiang Zhongke Electric Code Ltd, and for electrolytic iron ground rod is Xinjiang Country Alloy Federal New Material. So for the model code for copper rod is ZKER/17, and for electrolytic is AF-0200. So for the cost for copper rod is US $10, or in ringgit Malaysia is 44.04 for one piece of copper rod. And the cost for electrolytic iron ground rod is $100 or 440.45 ringgit per pieces. Application of copper rod for 152 kV grounding is a ground rod ZKE70 or ground rod field only purpose in life is to have designed electrical path to dissipate static disturbance such as lightning to earth. A thin ground rod with competitive price is made of high quality copper. The steel core is low carbon steel and the carbon content about 0.50% only. It's very uniform copper layer and the thickness of 0.254 mm or more. Products have conductive properties of copper and the tensile strength of steel. Since the copper layer and steel material is binding molecule, copper layer not easily peel off and will not crack when bent in pressure. Okay, the part for application of electrolytic iron ground rod, we can see that chemical earth rod are widely used in power plants, substation, transmission line tower, communication, base station, airports, railways, all kind of high-rise building, microwave relay station, the network, computer room, rounding, oil refinery, or depots and other places to anti-static grounding, rotative grounding working, etc. Okay, for the first, let me see this picture, which is we can see that this the view of grounding in 132 kV substation. We can see that if the lightning occur here and the attack here, so the electric will go around this and go to this ground area. So this area is grounding, which is this for is copper that we use for grounding. Okay, for electrolytic electrode, we can see that there is wire that come from substation, and this is copper pipe, and this is some mixture that contain with salt, anything. Okay, if the lightning or electric current flow here, so the electric will go up through this mixture from this grounding. Okay, this design is more benefit because this mixture beside the moisture from air coming in more helping for the electric to lose in grounding because there are salt solution leaking out and bentonite clay the most helpful for electrical to lose in grounding.
Assalamualaikum. My name is Muhammad Kamal Amzar bin Kamal. I would like to present about advantage of copper rod. The advantage of copper rod is at least 12 times more conductive than steel and 250 times less magnetic. A very big difference indeed. When we design a ground grid for a substation, the reduction of hazardous step and touch voltage is our primary concern, not the grid resistance. Number 2, the copper rod is simple design and easy to install in good soil, hardware readily available, and lastly can be extended to reach the water table. Next, I would like to present about advantage of electrolytic iron ground rod. The advantage is this active electrode is the only grounding electrode that improves with age. Net advantage, low impedance to effectively dissipate lightning and electrical fault currents. Next, contain natural electrolytic salts which permeate into the surrounding soil to condition the soil and increase its conductivity. Next advantage, available in continuous sections up to 10 feet in length. And last, service life up to 50 years. Next, I want to present about disadvantages of copper rod. The disadvantages is high impedance, hard to install in rocky soil, and step voltage on earth surface can be high under large fault currents or during a direct lightning strike. The disadvantages of electrolytic iron ground rod is higher cost, can be overly labor intensive and time consuming to install, and last, it also has some poor electrical properties. I would like to present about conclusion. There are 3 points I get in conclusion. First point is electrolytic iron ground rod because it contains natural electrolytic salts which permeate into the surrounding soil to condition the soil and increase its conductivity. Second point, electrolytic iron ground rod can continuous sections up to 10 feet in length and life expectancy up to 50 years. Last, low impedance to effectively dissipate lightning and electrical fault currents. That's all for me. Thank you.